All right. Now it's 3 o'clock here in Copenhagen, and I just want to say welcome to all of you. I'm really excited to be with you in this subject because it really, if you're a coffee roaster, this is something that touches your life and how you focus, and therefore where you spend your energy, and also affects the types of results or not that you get. So I will share the presentation, and there's been a lot of asking about if this will be available later. Yes, I am recording this, just also so that you know in term if you ask some questions. But also, if you're not able to be here all the time, it will be recorded and uploaded to our YouTube channel. There is an offer in the end. So all of you who sticks to the end, you will get an amazing offer, basically all our digital products with 76% discount. And that's only available for 24 hours. So if you are not able to hear the end of this presentation, you can still, before 24 hours, go to YouTube, go all the way to the end, and scan the QR code and get the offer. But the whole point is that I'd like you to see the whole thing and understand the perspective, and also how we can save you a lot of time and get you more deliberate results than normally. Oh, there are. All right, there's just people in the Q&A already saying hi, which is great. Great, and you can also hear me. Could somebody in the Q&A just kind of confirm that you can all hear me? That would be very awkward if that's not the case. Yes, we hear you. Okay. Thanks a lot. Great. So the title is a bit provocative, but I'm really serious about this. Why rate of rise is a bad reference point for optimizing flavor in coffee roasting. And as I just mentioned, for those of you who stick around, there's this offer available in the end of the presentation, where you can basically get all our digital products for nothing. And it will help you really get started on CoffeeMind's simplistic approach that will give you the results you're looking for and not a lot of confusion. So who is this for? It's of course, the title is only appealing to people who know something about coffee roasting, right? Otherwise, you wouldn't know what rate of rise is. So it's definitely for coffee professionals who knows about coffee roasting. But even startup roasters, in order for you to make sure to spend time on the concept that matters and avoid the ones that doesn't, this will save you a lot of time. And prosumers, private people, I found that they are actually going to the whole coffee roasting as seriously as coffee roasters, and are using the same concepts. So it's really for all of you. CoffeeMind, for those of you who don't know, it's basically me and Ida Steen. I'm the coffee roasting geek, and Ida is a sensory scientist, and she actually is doing a PhD in the company where she is working with optimizing sensory learning. So basically, the education systems out there are not evidence-based, they are not scientific, and Ida is the first one to create a comprehensive sensory training system that is evidence-based. And we just this Monday, we got the first scientific article documenting the effect of her training. We got that accepted for publication. So hopefully in the end of this week or next week, you can read all about the effect of her training system, which is a 4-week training system, which is available on our website. And you'll get, that's part of the offer you'll get at the end of this presentation. Basically, you'll get an incredible offer also on Ida's 4-week sensory learning, which comes with a kit. So there's something to train every day for 4 weeks. coffee, basic taste, aromas, and a lot of things. She's compiled a small package for you. But we focus on education consultancy, and we've done a lot of research. We've got 11 scientific articles now out, all on coffee roasting and sensory science. We are here in Copenhagen, and you can see on this picture, I just took all our roasters. Basically, we have them all here in a small area where you can try out 6 different brands of roasters that are already. It's just to go and turn them on, and you can roast. So we do all the SCA courses here and start to do our own curriculum as well. And we are based here in Copenhagen, Denmark, which is in Northern Europe. Yeah, as I just a bit about our background. We have been teaching more than 2,000 individuals coffee roasting and sensory science or sensory skills, and I have actually been teaching more than 1,600 individuals in small groups of 6 to 8 coffee roasting here in Copenhagen and at London School of Coffee. So I've been speaking a lot about coffee roasting with students. We've consulted a lot, of course, more than 30 roasteries worldwide, and we've initiated more than 30 scientific research projects, of which 11 are now published. And our approach is that we don't want to give you a fish, we want to teach you how to fish. And this is very relevant when it comes to coffee roasting, because if you are following under somebody else's curves or are using advice at the curve level from others, then you really don't know what you're doing. And what this exposes is your insecurity in your own sensory skills. And this is where we focus a lot on sensory training, because we don't want to give you curves. We want to teach you how to control your roaster and also how to do experimentation. And then we want you to evaluate your own result. And the whole experimentation part is such an important thing, which is basically, this is why research design is so relevant for coffee roasters, because you're doing experiments all the time, and there's a lot of really fundamental concepts you need to know in order to not make wrong conclusions. And the rate of rise recommendation is a really good example of how research design can help us kind of avoid those kind of wrong focus points and wrong concepts. And so we don't want to really show you a curve. We want to teach you how to experiment and make your own conclusions based on trusting your own sensory skills. And this is not just my opinion. I'm not saying I'm writing everything I'm saying, but I'm saying that Beat and we are basing our methods on all the best practices when it comes to methodology from science, all the way back to Plato, and then across all the different isms, critical rationalism, Occams razor, empiricism, and of course, statistical inference. And if you want to go much deeper than we have time for today, please subscribe to our podcast, where I have 7 episodes where I'm going through scientific theory and research design. That's very valuable, so that this way you will get it an even deeper level than we'll go through today. Just to give you, so Coffee Mind is all about simplicity and really keeping things as simple as they really are. And my background for doing exactly this was that I was employed without knowing anything about coffee roasting. We had this L12 coffee roaster that I think was, looking back, it's the least helpful piece of equipment, I think, developed ever, because it's kind of thermostat regulated. So I had to, if I wanted to modulate the flame, I had to jiggle the on-off button. So controlling a roaster by trying kind of taking it half on and just see the flame, if you think you are kind of only have half flame, it's a very awkward way of going about it. And but I learned how to brown the beans just by Kurt, the CEO at this company. And basically, I didn't know what I was doing. I just followed order. Then we got this 30-kilo roaster, and nobody knew how to operate it. And I was kind of, oh my God, this company already. Well, this was 1.5 years into the business, and and Contra already had a lot of customers, and I was responsible for kind of getting a new roaster and making sure that the products taste the same. And having studied biology, I thought I knew nothing, but I thought, okay, if I keep it simple, there's 12% moisture in greens. I heard that. It takes a lot of energy to get rid of moisture. So I probably need to add most energy in the beginning. And then as it becomes drier, I need to kind of reduce the amount of energy I add all the time, because as it becomes drier, the heat capacity becomes lower, which means that the temperature goes up faster. And that's a very simple thermodynamic principle, because it takes a lot of energy to heat water. And once it's dry, you have to back off. And then I thought there must be a correlation between just the color intensity of the beans and the flavor, because it must be the color intensity of the beans must be a kind of an indicator of how far the chemical reaction has progressed. And kind of using that, and then I also knew that time was important from kinetics in biochemistry. Time is so important because basically a chemical reaction is a random event. So it's not, if you have a material, it's not all of the possible chemical reaction will not just happen once. They will happen by coincidence. So if you have a temperature, the time you keep the material at that temperature is a part of the describing the chemical reaction and the speed and the progression. So I kind of thought a lot less and least energy in the roasting process, and just make sure that the time is the same as your roaster and the color. And basically what I did worked. People were happy with the products. And I'm not saying that somebody really skilled couldn't taste the difference, but it was good enough for the purpose. And I still think that this is the most fundamental and simple understanding of coffee roasting. And you don't have to obsess about small things on the curve, because, and I've tested this, people cannot taste small differences. And I'll show you data on this later. But there's a lot of good stories, but that's not the same as getting it tested. So that's my background. I didn't know anything. And after I did this, I really felt, okay, I understand it. And later I went to South Korea as a consultant, just half a year after, and I could help people with this simple method. And that led me to start my teaching at London School of Coffee in 2007. Now, as I said, I've been training thousands and thousands of students in small groups like this. And I absolutely love it. It's my favorite people to be with. So every year I do this, I'm more and more happy hanging out with coffee roasters. There's a certain flavor to us, which is great. And for me, it was a huge milestone to get to know Ida and her methods. So basically, I did a lot of, as I just said, I started to learn how to roast, and I started to learn how to control the roast, and I was pretty happy with the sensory result. But I started to kind of get more and more deep in the questions about how does the body of the coffee depend on the development time, and what about the acidity that goes up and down as with longer and shorter development time. I started to develop a lot of hypotheses on how it was related. And then I started a project at the university, and this is where I met Ida. And we did some work together, and here I really understood what scientific sensory method is, and how far it is from what's done in the business. So I was really excited about the possibilities I saw, and Ida and I talked a lot about this, and we actually got the idea to her PhD project already 8 years ago. And this or next week we'll have the first article out. So you have to be patient to get things done when it's science. So for me, getting the sensory competency in the house was so important, because for me, a coffee roaster stands on two legs. One is control and experimentation, and another one is sensory evaluation. If you can't trust your sensory evaluation, you do not have a compass. So that's your compass, right? So I just felt it was so important that I just really wanted Coffee Mind to be not only me, but Ida with sensory science as well. And this has completely transformed the way that we work with product development, quality control, and how we focus on everything coffee roasting. And Ida's revolutionizing herself the whole way sensory education is done, which is also relevant for green coffee purchasing and baristas and all that. But Coffee Mind's primary focus is coffee roasters, and certainly it's very relevant here. And as you can see here, I just want to tell you two things about sensory science, which is you have two very different things you can do in sensory science. One thing is that you can map out intensities in the laboratory, intensities only, not qualities or preferences. So you can see here on the left picture, this is Ida in the lab running a scientific intensity mapping exercise, right? And then the consumer side of it is completely different. You can see on the right side, we have this guy. You can see it this, on another picture, we can see that he's got a cigarette. So I'm not saying all consumers looks like that, but he's just a really nice example of a consumer who's not too quality oriented. But consumers can be quality oriented. That's not my point. But the whole point is that you ask very different questions when you ask about preferences, where you have to be very aware who you ask, because in the consumer part of it, you're not really learning anything about the coffee. You did that in the lab. In the consumer part of it, you learn something about the consumer, the preference of the consumer, and they can be very different. But this is basically what you see here in this picture is the two very different sub methods or sub disciplines in sensory science. So it's called consumer and sensory science, or sensory consumer science. Oh, I'm just speaking, and I can see there are actually questions or comments. Okay, that's you could hear me. That's great. All right. So I want to introduce the concept now that you all came here to hear about, which is our approach versus the rate of rise approach. So you can see here from the research, we found out that if you have a particular green coffee, let's say you have a green coffee, the possible flavor space of this particular green coffee is kind of determined 80% by the color intensity that you end the roast at, and only 20% of the overall timing aspect of the roasting, which means that you cannot ignore color from a quality control perspective, right? If you are trying to control the flavor, you need to control color. So color is a necessary, but of course not sufficient, because timing is also important. But color is the number one thing you need to make sure is the same. And also when you do an experiment, if you do a drum speed experiment, airflow experiment, or any other experiments, you cannot have difference in color. And this is the number one problem I see when people doing experiments. You are doing experiments. You need to know the fundamental concepts. And one of them is the everything else equal principle. So if you're doing an experiment, you are experimenting with one parameter, one input parameter. And if that's drum speed, you cannot also have differences in color in the coffees you are ending up with. Because if you have, for sure, it's the color differences on the table that will lead you to have a preference rather than the experiment you thought you did. And then my good friend in Paris, George Karam, told me, yeah, that's good. I understand, I get it, Morten. But is it true then that if you keep the color the same, let's say in a product development phase, then all of a sudden the timing is the only thing you are changing, and then you kind of have to explain that, all right, if you keep the color the same, then all of a sudden the 15 and 5, the 15% development time and the 5% to first crack, all of a sudden has some bigger percentages in your experiment, because it seems like the 5% that time to first crack impacts the flavor. It seems like it's nothing, but it's not nothing. 5% is something, particularly if you have a very skilled palate. which is what most people in the specialty coffee business has, and who typically, for example, roast light. Then all of a sudden, if you keep the color constant, then the 20% of time is all of a sudden 100%, right? Because that's the only, now timing is the only thing you're changing. And then all of a sudden, development time is 75%, and time to first crack 25%. I hope this makes sense. Otherwise, you can go back and listen to this a couple of more times when I release this on YouTube. But this is a framework for you to prioritize your focus in different settings. So this is such an important point. Okay, so before going into the whole rate of rise discussion on why it doesn't make sense in a lot of the context that it's used, first I'll go through what it can be used for, where it does make sense. So as you can see here on the graph, rate of rise is the speed of the bean curve at any given moment, right? So you can see you could, if you have a pointer of interest, you can kind of draw a line, and then you can calculate the slope of that line, because this line represents the slope of the curve in the point of interest. So it gives you the speed of the curve at a lot of different points. And can you see here, then the rate of rise curve that you can draw is actually not extra information. You already have it. It's already the shape of the curve you already see. So it's not extra information. It just looks like a very advanced thing to look at if it's drawn separately, but really it's already there. It's just the shape of the curve. But you can use it, for example, if you know that you'd like to hit first crack at 9 minutes, and you are at 6 minutes, and you are 30 degrees off, 30 degrees from the temperature point where you typically get first crack. And if you get first crack at 200 and you're at 170, it's 30 degrees before you should hit first crack temperature wise. And if you've got 12% rate of rise, and you know your rate of rise is going down, it seems like you will pretty much be there, right? So you can use it to see if you will be, just like the speedometer in your car, if you will be early, late, or on time for your meeting. So you can use it to kind of see if you are going the right direction with your roast. And I'll explain later that I would never improvise. I would never make a decision based on it. And that's why I don't want to obsess about it. But technically that's what it can be used for. You can use it to categorize your roast because, as we've seen in our research, if you have a shorter development time, your coffees will be more fruitier. If you have a longer development time, it will be more chocolatey and bitter, higher in bitterness. And so you can kind of categorize your roast, your fruit forward. You would have short development time. And if you want to make it a bit more pleasing for people who are not too happy with acidity, you can keep the color, but you can just shave off a bit of the acidity by extending the development time. So you can kind of use it to categorize your different types of profiles that you have in your library. So I'm not saying, and because if you keep the color the same, a shorter development time will have a steeper curve, which translates into a higher rate of rise. And if you keep the color the same, but have a longer development time, you will have a lower rate of rise number-wise. So you can kind of use it, but that's pretty simple, right? But I think this is what you can use it for. So it's not much, but it's okay. So if you understand this slide, you understand sensory science. And as I said, with Ida and her methods from sensory science, that's our compass, right? So sensory science is not understanding aroma chemistry or flavor chemistry or taste chemistry. It's a method to make sure you spend your time where it matters. So understanding sensory science is not difficult. You just need to understand the fundamental distinction created by Rosemary Pangborn at UC Davis 50 years ago. And the fundamental distinctions in sensory science is if somebody has a claim, right? If somebody says that this fertilizer will make it taste this better, or it's shade grown versus sun grown, or the curve needs to look like this, or drum speed, this is better than that, then the first thing that Rosemary would ask you, all right, well, it sounds like an interesting theory, but let's just see if we can taste the difference at all, okay? Because if we can, we shouldn't spend too much time on that theory. So this is done in a very quick kitchen test first with some triangles. And if you cannot taste the difference, there's no reason to obsess about that it's difference at all, which would be the next step. If you find that there's a difference, then you would like to describe the difference. And that's what's done in the lab with intensities. So here, for example, you can see if you have got 3 samples, light, medium, and dark roast of the same coffee, I hope you agree that we would be able to taste the difference, right? If it's big differences in color, let's say Actron 65, 85, and 105. Of course, we can taste the difference if the color difference is that big. All right, so we could taste the difference. And then next step, once we've proven that we can taste the difference, then we would like to describe the difference. And that's what you do in the lab with intensities, mapping out intensities. And here we would find that the light one is high in acidity and low in bitterness. And the dark one is high in bitterness and low in acidity. And the medium is kind of medium on both. Very simple. And the next question is, who likes what? Because why? And this is such an important kind of misunderstanding in the specialty coffee community, and has been, I think, a catastrophe for serious product development and business strategy when it comes to consumers in the specialty coffee business for, I don't know, 50 years. It's kind of not assuming that you have a universal yardstick for quality, that there's something that's better than something else. And according to Rosemary, she would never ever make that mistake of trying to assume quality for others. It might be that I prefer the light one, but from an educational perspective, where I think us as educators, we should be able to educate people to whatever situation. I don't think we should paint people into a preference corner in the education situation. We should give people tools, and then they can figure out where they want to go later, right? If you get a car, you don't want to be told only to drive in Copenhagen. What if I want to go to Spain, right? It's the same here. So once the intensities are mapped out in the lab, next thing is to expose different customer segments for it. And then you will find that there will be different likings. So hipsters like us, we prefer light roast. And then there's the kind of the latte segment. They don't like the lightest roast. They are not probably, they've kind of grown out of Starbucks, but so they probably prefer medium. And then this guy with a cigarette in the right hand is probably him, right? It's okay. That's what he prefers. Good, strong cup of coffee. So the important thing here is that this is sensory science. Sensory science would ask the questions in this sequence and has very elaborate objective methods to get reliable data in each step of these. And most of the theories that we are working with in the education community in coffee roasting wouldn't pass the first test, okay? Which is very important because we are wasting a lot of time and we're not even clear about how is it different, right? And this is where the rate of rise theory is kind of, well, there's a lot of problems. You can't even make the experiment because you cannot keep everything else equal. And if you could, the differences that is dealt with is so small that nobody can taste the difference, in which case it doesn't make sense to describe the difference. And it doesn't make sense to kind of assume that it's optimum, because for whom, it's not specific about who is it optimum for. So in Coffee Mind's roasting education system, we have implemented the sensory science part exactly in this way, that first you learn to control your machine. And again, using Pangborn's first model, there's something about consistency. There's a limit to how consistent you need your roaster to be. Don't freak out if there's kind of plus minus 30 seconds. Nobody can taste the difference. So sometimes I see people over obsessing about consistency without thinking. But the first thing you need to know is what's consistent enough, right? So you shouldn't add a lot of complexity to what you're doing if the complexity you're adding doesn't make a difference anyway, right? So you just need sufficient consistency. And I've made a method with which you can get sufficient consistency on your machine. So you get to know your machine just like I got to know the 30 kilo roaster in a few days in 2006, right? It's enough. When you have sufficient consistency and know your machine, you can go to the experimentation part. And if you trust your own sensory skills, you can evaluate, right? Then you can evaluate the intensities. How does it taste different? And then you can go to the consumer step, where you can either decide not to serve the dark roast, or you can serve the dark roast, but then you would need to be able, you need to screen, who do I serve this for? So you need to be conscious about your customer model and the preferences related to the different customer segments. So I just said sufficient consistency, right? And that's because I see people over obsessed about small stuff. So what I've done, well, we did this in the research, right? We showed that people struggle to taste the difference in timing, right? But this was the research we did here was reported in a slightly kind of strange way because it's descriptive analysis with linear regression and stuff. So it's difficult for coffee roasters to really relate. So I've started to collect data during roasting professional courses where we are serving extreme differences. We are serving extreme differences in timing. Of course, we are serving light and dark, but those are the easy ones. But I've created 3 different extremes when it comes to timing. And on the Ikawa here, you can see I've got these 3 extreme differences in timing, and I call it scorched, baked, and underdeveloped. Please forget about the labels. I actually regret ever having it. It was in 2014. I wanted to make a better and more systematic framework for roasting defects than the SCAA system that I found very anecdotal. So I kind of thought I need to make some systematic differences. But for me, I would just prefer to talk about time to first crack, development time, rather than baked, underdeveloped, scorched, whatever, because it's difficult to make any universal claims anyway. So just think about the scorched one. You can see the left one, the lower left. It's extremely fast. It's the fastest roast the Loring can create. So this roast profile basically maxes out, not the Loring, the Ikawa. It's the fastest curve the roaster can make because it maxes out the heat source. So the fastest possible, but same color as the reference. So you can see my reference roast here, 6.5 minute total roast time. It's actually a simplified version of an Ikawa roast profile from Tim Vendelbo. We did a project together many years ago on fertilization, and we worked a bit on my Probertino here and the Ikawa, and found out that approximately 6.5 minutes on the Ikawa matches the Probertino. And Mark Alchimeri and I will go deeper in this. He promised me that's one of my new coffee roaster science friends. He's basically working a lot with thermodynamics of coffee roasting, and I cannot explain, which annoys me, why roast on the Ikawa needs to be so much shorter than pilot roasters. And I have a lot of good ideas and hypotheses, but But I don't want to kind of go into all my ideas. So just a few questions. Ben Roberts, you asked, what tools do you use to measure coffee color? And I think I have all of them: color track, diabalytic bench, Lightells, Tonino. Yeah, I've got a lot. And then also there's, could you please define color, Anja Ran? That's a really good question. And this is something that I've really found out that it's my Dinglish. I'm not a native English speaker. So I found out from a photographer who was on my course last week that I should call it color intensity, because it's really grayscale. And I've actually done a university project where we tested different wavelengths up against the Actron M Basic, at the 10,000 euro, and we found out it actually doesn't matter which wavelength you use; they are all as good as correlating with the gold standard Actron. So it's just the intensity. It's basically a grayscale kind of range. So color intensity is the total amount of light, so to speak, reflected by the sample. How many participants did attend your studies? Have you asked to get confidence about this scientific study result? Yeah, we have. I can tell you that we have 18,500 data points in our in this study. That's enough. So it's across, I think, more than 120 people in a laboratory setting. Okay, I think I'll take the rest of the questions later, but I just wanted to make sure to answer some of them. So the point here is that you can see the scorched one is very short when it comes to time to first crack and development time. So development time is from first crack to end of roast. And then the other extreme, the baked one, and that's just my definition of baked. There are several out there, but the baked to me is a kind of chemical defect, if you keep it too long at least, where it's just kept at the same temperature for too long. So here you can see it's got the same time to first crack and same color as the reference, but I doubled the development time. And the underdeveloped, I would prefer just to call it time to first crack. You can see I also doubled the time to first crack, so it was 8 minutes rather than 4, as with the reference. So the trick here is they are all the same color. The scorched, baked, underdeveloped, and reference is the same color. And because it's the same color intensity, people really struggle to taste the difference. So in the roasting professional, people really want to pass. I want people to pass because they travel far. They've been taking the intermediate 6 months ago. They've been, or more, and they've been roasting professionally for years, and they really want to pass. I want them to pass. I train them the day before. They are trained on the day, and then they are served 5 triangles, one scorched, where one triangle where the scorched is the odd cup up against 2 references, another triangle where the baked samples is up against 2 references, and so forth for all the extremes. And you can see here, everybody can pick out the odd cup. So the red columns is the odd cup, and so there are skills in identifying the odd cup in the triangle, and everybody can do that when the odd cup is the dark one. And then you can see it goes down. So the light, it's actually not, it's surprising. So, and then the baked and the scorched and the underdeveloped, it's really, really low. And you can see only 23% are able to identify it because they are asked to first differentiate which one is the odd cup. And if they get it right, we also ask them which one is it, the odd cup, which of the 5 extremes is it? And people are just not able to convincingly identify it. And notice here, this is 4 minutes added to first crack, and only 23% are able to guess which one it is. And if you notice here, you can see they can guess from 5 different. So 20% would be the random correct answer, and here you can see 33% would be the random correct answer on the triangulation. So this is really disappointing if you trust that people are roasting professionals, and you have to trust that these are amongst the best in the business. Of course, there are better that never does the SCA courses. That's not what I'm saying. But if these people are not able to just pick out an underdeveloped up against a baked and a scorched and a reference here, then it seems like people are just over exaggerating a lot of things, right? You can see here, most of the things people are claiming to taste difference would never pass the first part of Pangborn's test here, the discrimination test. You can see people could hardly taste the difference between the underdeveloped and the reference. So this then leads to our overall framework that I've done another webinar about. You can see here where we've got different competency pillars that you need to acquire if you want to be a coffee roaster who knows what you're doing, basically. So you can see here, first you need to have a vision, how between your life vision and your company vision. And then you need to be able to control your facilities, right, in the thermodynamic blueprint, the standard roast exercise that I've developed. Once you have control, it's your skills in do experimentation that is important, and you need to be able to evaluate your your experiments yourself using proper research design. Then there is the quality control step. You don't need the same narrow range for all your segments. Some you need and some not. And this is also why people are over obsessing with consistency and other things without being conscious about the whole purpose. And the purpose is the dynamics between your product and your consumers, right? And this is where you need to be able to address different consumers differently, and have some kind of educational strategy if you have a range of products that where it's not one size fits all. But this is a longer discussion. But it's just to show you how our overall competency framework that can take people from being a coffee roastery starter or beginner to really create your perfect organization. All the competency pillars are based on science. And as I mentioned earlier, if you have a system, if you have a system you are controlling, you need to be very conscious about what is the most fundamental parameter, what is the parameter that I directly control. That's probably the most important one, right? And in coffee roasting, it is the heat source. So you have a heat source that heats up something in between the heat source and the beans, primarily air, but there's also some metal. So you have got this kind of causal relationship from heat source to medium between heat source and beans, and then the beans that are heated up. So you can see, then you can track the bean probe and the air temperature probe. And these are artifacts, right? Because you can get some coffee roasters, for example, the Bullet here and the Stronghold they have infrared thermometers, and I'll show you later. They'll show you something very interesting. So basically, you can see the bean temperature probe is pretty artifact burdened already, right? It starts high and then go low and eventually up. That's okay, but it's just, for me, the bean probe just tells me how far am I really from first crack, right? Or how far am I from first crack to the color? It doesn't really tell me anything. All my machines has different temperature for first crack, so it's not the correct temperature anyway. Different positions, different thicknesses. So it's not really a very it's a pretty relative reading already, right? So, and you already have the shape of the curve, as I told you. So remember that it's the relationship between the flame and the beans. That's the main thing you need to be able to control. And this is where your intuition is built with your particular machine. And this is why developing the standard roast will give you exactly those skills, so that you have intuition, so that roasting coffee is just like playing Angry Birds. You know exactly how the machine will behave once you do this, and you don't need to interfere and play around and fiddle with the flame, as I see a lot of people do when they kind of try to apply the constant declining rate of rise. Then they are jiggling the flame all the time as if it makes a difference. So I want it to be as simple as playing Angry Birds. And in Angry Birds, once you've let go on the bird, you don't touch it anymore, right? So that's how simple coffee roasting should be. So the constant declining rate of rise is a pretty natural thing to happen in the roaster anyway, right? Here, if you have a constant temperature, a constant air temperature and I tried to do this on the Kawa. If you have a constant air temperature in your system, you'll get this situation that is illustrated here. It's the temperature difference between two substances that will determine the speed with which the energy is exchanged. And it was actually a coincidence that Reza just served me a hot cup of coffee, because I have this is my old cup of coffee and this is the fresh cup of coffee. If I take the old cup of coffee, which is cold now, so I can feel, oh, now the energy goes from my hand to the cup. And if I take the hot cup of coffee, I can feel that now it's reversed. It's the energy now, the heat energy goes from the cup to my hand. So the bigger the temperature difference, the quicker the energy exchange. And as the temperature goes closer, as the bean temperature goes up, because it's heated up by the air, the temperature difference becomes smaller, and then the heating up becomes slower. So you can see how the bean temperature will actually go asymptotically, as it's called in English, against the air temperature. It will go closer and closer, slower and slower, without never really reaching it. And then the rate of rise will do this also naturally. So, and also, as I said, I would go max with the flame in the beginning, then less and least in the end. And that will actually make this constant rate of rise happening even more. But I wouldn't obsess about that, because it isn't an indicator for anything anyway to really make it precise. It's just a natural consequence of what's going on. So it's not something to focus on. And you can also see here, this is from the bullet roaster. Here you can see we've got the infrared thermometers measuring from room temperature, because the green coffee is room temperature when you put it in, and then the temperature goes up. And then you can see the bean probe starts artificially high, and you can see these are different, right? And then you can see they actually crush each other at some point. And you can see it seems like the bean probe over exaggerates, because the infrared thermometer measures the temperature of the surface of the beans. So it seems like the bean probe gets some signal from between the beans. So it might be the exothermic reaction that starts to heat up the air between the beans, because it seems like it goes up more and more, right? Which is a reason for always adding less and less energy. But my point here is that this was actually with a constant flame or constant setting on the bullet. It's just to show you how the rate of rise behaves if you keep the energy input constant. And also you can see here you've got different rate of rise curves for the bean probe and the infrared. So which one to smoothen out, right? Yeah, they follow each other a bit, but it seems like there's a big problem to solve here on the bean probe, where on the infrared there's no problem here. So can you see how different bean probes would give you different things to smoothen, even in the same roaster? So which one to trust? So that also makes it a very fluffy reference point, right? So this slide, I kind of realized when I built it yesterday, it's not the most easy to read. But the whole idea with this slide is to illustrate for you that a, a scientific, or not just a scientific, a theory to make sense as a theory has to have a very simple structure, such as cause and effect. In any theory, you claim to have found out that if I do this, that happens. That's the essence of a theory, right? I do this, and then that happens. Cause and effect, input, output, independent variable and dependent variable, as it's called in research design. And then you can see if that's the essence of a theory, it's very important to be specific about the cause and specific about the effect. And if you follow what is called Occams razor in theory of science, if you don't know what that is, please listen to the podcast where I go deep in this. The independent variable and the dependent variable, or the cause and effect in a theory, needs to be formulated based on the simplest possible concept with fewest assumptions. Okay, so you can see in the theory of constantly declining rate of rise, and I see people are asking questions, but I think it's better that I'll go through the presentation and then we take all the questions later, and then I'll go back to the slides, because otherwise it's difficult to kind of keep the timing, which is difficult enough already. So be patient with the questions. I promise I'll go through with them later. So the idea here is that it needs to be as simple as possible with fewest possible assumptions. So the idea that the constantly declining rate of rise will give you a superior flavor. One of the problems you can see, so it's constant declining rate of rise, shape of the beam curve, superior flavor as the effect or output, right? So you can see here, the beam probe, for all the reasons I mentioned earlier, the beam probe in itself already has a lot of confounding and a lot of weird assumptions and artifacts already, and it's a relative reading. It's not an absolute reading. First crack, target temperature, color intensity, that is specific, absolute concepts to use, and not the shape of the rate of rise curve. It's such a flimsy concept to use as an input in a theory for all the reasons I mentioned. Then look at the dependent variable. What is predicted? What is it as it's better? Well, how is it better? In which case is it better? And also sometimes I've seen people say it's baked if it happens. And remember, categories are for big differences. If you just change something a bit, it doesn't switch into a completely different category just like this. Remember that I doubled the development time of the baked, and people could not really just pick it out, right? And then if you cannot just clearly pick it out, it's not a different category. It might just be that the bitterness and acidity has shifted a bit, but that doesn't make it a new category. So that's one thing. If it's formulated with categorical variables, it would have to explain big differences. And I've already added 2.5 minutes to development time. That was 2.5 minutes already. And it wasn't even enough to make it a separate category. And then it's not very likely that it's big differences enough in this constant declining rate of rise to make it relevant as a theory to shift a category in flavor. So, and another thing is that you can see here the arrow between the cause and effect. That's kind of the mechanism, the expected mechanism that causes this relationship between cause and effect. And it has to be established in some already well-established physical or chemical theory. And I think that the discipline of kinetics, so the speed of chemical reactions, and also the ideal gas law, that's the kind of explanations we should be looking for, right? So for example, when you can see it seems like it's cooled down a bit around first crack, that might be because the volume goes up. If the volume goes up, the temperature goes down. That's how a fridge works. It's how a snow cannon works, where you have pressurized air, pressurized gas in a fridge that is then released into low pressure, and then there's a temperature drop. It's very natural. That's the ideal gas law, but it doesn't necessarily affect the beans too much. You can see the infrared is not really affected too much. It's more the in between the beans that is measured by the bean probe. So there's so many artifacts around reading the bean probe that makes it an unreliable input parameter. Yeah. So again, both independent and dependent parameters should be chosen carefully amongst the simple possibles and most specific concept with the fewest assumptions. Otherwise, it's difficult to be specific and therefore practical in the use of the theory. Temperature, time, color intensity, basic taste, flavor categories. Those are examples on something that is good to use as input-output in a theory, not derived values nor preference claims. So, and then the everything else equal principle I already mentioned earlier. If you make an experiment, you can only change one thing at the time. So, and you can't keep both development time and color constant when experiment with constant versus non-constant rate of rise. And that's because the constant rate of rise is a bad input parameter, because the independent variable has to be something you can easily set exactly how you want it. That's the idea with an independent variable in a research setting, that it's something you set, right? You can't, well, you give people the placebo or the active pill. You do that, right? That's the idea in an experiment. So it cannot be a flimsy thing that's difficult to control. Then it makes up for a bad experiment if you don't have full control of the independent variable. And that's why I want you to think more of the heat source as that in your system, rather than rate of rise, which is a kind of derived value in the third link of the causal chain in the system, right? So, and that's my point. So, as I mentioned, you already see the curve. You already see the shape of the curve. So you have the rate of rise already without calculating it separately, because it's the shape of the curve you already see. That's one thing. Another thing is, even if you see something, what you see is very small, right? So the theory is concerned about these small changes in the bean temperature, and you can see it's small, right? And the problem with the rate of rise curve is that there's a lot of noise on the signal, and the noise of the signal is if you take the temperature with the noise on that, and then you make a fraction, so temperature per time, then you magnify the noise, and there's also the software is calculating this live, which is there's a lot of trade-offs you need to kind of decide when you do that, which makes it even more noisy. So the signal goes up a lot, right? And my point is, if you kind of remember how roasting professionals struggled to taste the difference between these, can you imagine how different the rate of rise curves are for these roast profiles? Ridiculously different. And then this theory is asking you to over obsess about this that you can hardly see on the original curve, right? But if you calculate live while roasting the rate of rise, you'll get this magnification. And that's my point here with a small spider, that a small thing doesn't become more dangerous just because you magnify it. And that's another danger of deviating from just looking at the curve, right? You might over exaggerate something that's not even relevant. And notice how this is exactly what Pangborn tries to warn us against, right? You first have to get a feel of the magnitudes of flavor difference. Because if you can't taste the difference, there's no reason to kind of make a huge theory of how it's different and who likes what. It's a waste of time if if it doesn't even pass the first test. And this should be your Teflon brain against bad advice is, well, show me that the color is the same and that people who didn't know what they tasted could taste the difference at all, right? Okay, so Coffee Mind's approaches focus on the big things. Don't sweat the small stuff, right? So we know for a fact that color is very important. So in your product development phase, that needs to be your first decision. Many people they don't even think about color because, oh no, we roast light. Yeah, you roast light, but how light, right? You can make just a slight, make it a bit dark or a bit lighter. At least if you measure the color intensity of your experiments, then you know if it's the color intensity of the differences between the roast you did, or if it's something else, right? So you need to know the color intensity of all your experiments, because otherwise you don't know if that's the reason for the flavor differences. And also consider that a very fundamental parameter in product development in general. So in our framework, you start with, of course, choosing the green, choosing the color, and then choosing the development time. And then perhaps if people don't add milk, you can also play around with time to first crack, and then you're done. So we focus on the things that we know matters, where the constant declining rate of rise, I don't know how it makes a difference, and I don't know why it would be better. And if it's better, it can only be better for some and not for everybody. So we focus on only intensities, and we focus on the parameter that we've mapped out actually makes a difference. So it seems like focus on micro fluctuations is not a good way to spend your time, and it doesn't predict anything. So yeah, you can see we have such a simple model here. You choose your green based on the flavor goal you are looking for the customer segment you are addressing, and also think about the price, right? Flavor, quality, and price. You need to make sure that this matches. So if you want to compete with Tim Vendelbo in Oslo, don't skip on the green, right? Because people would care. But if you are creating a house blend for a local pub in the UK, perhaps you shouldn't get the most expensive. Well, there's a lot of gastropubs in London that might care. So it's not to point fingers, but you know what I mean. If you are creating a house blend for somebody who is adding a lot of milk anyway, don't get the most expensive cup of excellence coffee, right? So it's a trade-off, and it's a trade-off that makes sense in the light of the customers. Once you've chosen your green, you choose your color, choose development time, choose time to first crack if people don't add milk, and then heat source, airflow, drum speed. People are hiding in their basements trying to optimize it, and for me, I have some really simple practical ways of doing this and not really changing it at all later. So this is a framework that will help you focus on what matters when you develop a program or a product. There's one thing I forgot to kind of mention here, and that's aligned with so basically the need for the input parameters to be specific is rooted in what's called empiricism in our tradition of theory of science, where the idea was that you need to be so specific in explaining what you did so that somebody else could repeat your experiment and get the same result. So that's actually the idea of this is what makes it objective, right? If what happens is independent on the person executing it, it's an objective truth. So that's empiricism. So that's focused on the input parameters. The effect, the consequences is there's something called critical rationalism that kind of says, yeah, we need to be specific with the beginning, but we also need to be specific about what comes out, because some theories can explain everything, right? And that's annoying. So this was Karl Popper. He was really annoyed with theories that was always proving themselves regardless of what happened. If this happened, they could explain it. If the opposite happened, they could also explain it. And that's really a bad theory. And I think that's also the case with the idea of the superiority of the constant declining rate of rise. As better is such a loose and an unspecific claim that it's kind of a theory that doesn't predict anything. And if it doesn't predict anything, it can never be caught in being wrong. And then it can survive as an anecdote, as it has for many years, without ever really be caught in being wrong, because it didn't predict anything in the first place. So that's a very important feature of a theory, that it predicts something. So a theory should predict, does it become more or less acidic, more or less bitter? Because then the theory needs to kind of confine itself to one and only one specific outcome. If it doesn't, it's a theory that fits everything. And then people just think, oh, I made some nice curves and it looks scientific because it's kind of data, but this is where the methodology of science is so important. Okay, so yeah, this is just the process that I want to show you how you can make sure to control your machine and get an idea of the thermodynamic blueprint. It's a very simple exercise, and it's actually the exercise in the e-learning program that is normally sold for 30 euros. So for 30 euros, you can follow my instructions on how to expose the thermodynamic blueprint of your particular machine in your particular setup. And that's part of the bundle offer that you'll get later. So the idea is, remember, we are not with this. When you learn how to control your roaster, you're not going anywhere. Just like when you need to get to know how to drive your car, you will be starting on a confined track like this. You're not going anywhere. You will get back to start, right? But you're learning about your vehicle. So my standard roast is not a sensory preference. It's a pretty standard roast that will, if you solve it on your machine, you have an idea of the thermodynamics of your machine, not how to improve the flavor. That's later steps, right? So basically, this is the standard roast. How to get first crack in 9 minutes and 3-minute development time to the midway point that I call it, approximately X 75, using 3 and 3 flame settings only. Such a simple approach, full speed to second crack. It can be too fast, it can be too slow. The criteria, there are some specific numbers you need to reach, slightly arbitrary, but still you will end up with a picture of how your machine behaves in the beginning, middle, and end. And this is a method that I developed at London School of Coffee with the Diedrich HR1 and the Coffeetech FZ94. They only had three settings for the heat source. And there was never anything I couldn't do with my hundreds and hundreds of students when it came to show them flavor modulation in coffee. So I'm not telling you that, of course, at the experimentation stage, you can violate all the rules, but you'll be surprised how often you can solve what you need with only 3 flame settings. And the approach that I have is that you need to plan, execute, learn, never improvise. And that's also always what I see when people are kind of following the constant declining rate of rise. They are micromanaging the flame, fiddling around with this all the time. And that's a sign that you don't know your machine. Because if you are improvising, you are making a change too late anyway. You cannot save it. So it's much better that you take it to the bitter end with your bad plan, because the magnitude with which you need to fix the plan, you can only read from the data of sticking to the bitter end with the plan you had. You don't know if you will be kind of 25 seconds delayed or 1.5 minutes. And you need those data to create your next plan better, right? So that's why plan, execute, learn is the way that you get to know the thermodynamics of the machine. The second you start to improvise, you don't learn anything. And when people have done this, they can really intuitively control their machine, just feel what they need to do, and then it's happening. But only if you don't improvise. It's a very important point. And you can see how different my different machines are. They have very different thermodynamic blueprints. You can see the Probertino needs to be on for a longer time than the Stronghold and the Bullet. And if you add 2 kilos to the coffee tech, this is the thermodynamic blueprint. So you can also use this control method to dial in different batch sizes on the same roaster. So it's all about exposing the thermodynamics of what you're doing. Okay, that was actually what I wanted to tell you. So this is the secret QR code for you who want to progress on the Coffee Mind Simplicity kind of learning journey. And you can see here, I've made a bundle here where you get 2 e-learning courses, my Roast Profile Design Basics, EDA Sensory Basics that are normally sold for 30 euros each, and then all our PDFs and other frameworks, all our scientific papers, the flavor wheel, of course, cupping form, color correlation framework where you can work with different equipment and translate different color intensity readings. I've released my color palette, the 3D printing of the color palette. I'll just show you the wooden version is this one. But I've released the 3D print, so you can just print your own. If you get this, you can just get the step file and you can print it yourself. And then our 2 foundation books. Normally it's sold for 205 euros, but if you scan this code, you'll get on a landing page where you can get this for only 50 euros. And after accepting that bundle, you'll be taken to an optional upsell where you can get both EDA's scientifically proven sensory skills improvement for a week with a small kit that you will get sent. That will be added shipping. And you will get that for 200 euros if you act within the next 24 hours. And normally it's sold for 250 euros, but you will get it for 200. And then you can also jump on my 7-hour online live roasting classes on the Bullet, Ikawa or Stronghold, where for 7 hours we will be doing all the practical things or the exercises that that I've been talking about in this webinar on your particular machine. So now it's time for Q&A. So I'll just take them one by one. So Chris, when you say total development time, are we talking total time of roast or they're from first crack? It's from first crack. And of course, there's a bit of handcraft in identifying first crack. But it's basically the end of the roast. So if one person is logging it a bit before another, it doesn't really matter, because as long as it's the same person logging, then the relative differences on the cupping table will be the feedback to which one is preferred for the customers you are developing it for. Guy, how fast and slow development time? Yeah, fast and slow development time. In our research, we had to go a bit extreme to make sure to get good sensory data. So the shortest development time we had was 1 minute and 20. And I would very rarely go below 1 minute. If you really have high quality greens, you can create a fruit brum by having a shorter development time, but at some point it will flip over and be grassy. And then development times in the research, it was up to 6.5 minutes, but that's ridiculous. But that's according to our research. The shortest was 1 minute and 20. Oh, Hero, you have a very long mention previous blog. You kept flame setting constant through the row system. Pretty stable. Oh, that's a very long question. Yeah, so if you consider that a few small fluctuations and from sensory quality perspective is not resulting in any disturbing flavor, then my question is, what is if the disturbing flavor is detected? Should I adjust the gas setting to achieve smooth rate of rise, or would you suggest other way? So my point is not the rate of rise is there, right? It's always there because it's just the shape of the curve. So according to kinetics, it's time and temperature and color intensity. That's the three specific concepts that you can use with the fewest possible assumptions, right? You know what temperature is, you know what color intensity is, and you know what time is. That's physical entities. It's not, there's no assumptions behind that. So I would just basically you've got how you set your flame and how your curve behaves over time and the color intensity. So if you just, so it's not because the rate of rise is wrong, because it's there, but you don't need to use it for interpretations. It's more a question about how, and I think, so the speed of the roast after first crack, I think it is as simple as if you roast faster, the center is greener, and if you roast with a longer development time and hit the same color, the center will be less green or more roasted. And that's probably the only reason why it tastes different, right? So the reason that things taste different is not some weird mathematical shape that kind of makes something happen over something else. It's not that you can do this and then the Maillard reaction will go in another direction or something. It's just how dark does it get, and is there a gradient? That's it. So just don't think that you should attach any meaning to the rate of rise. It's there, but speculating of the meaning and how it influences the flavor, I would just stick to time, temperature, and color intensity. Nicholas, could you explain the underdeveloped graph, please? It is because we are not, yeah, the underdeveloped graph, the whole idea with the differences between the underdeveloped and the baked was that I just wanted to create a systematic approach as opposed to the SCA anecdotal approach. I feel so I wanted to make, so the baked is extended in the end of the roast and the underdeveloped is extended in the beginning of the roast. So the baked is kept chemically for a long time at the same temperature, where the underdeveloped, the pressure development is slower. So that's more like a physical difference. So I just wanted to be, I wanted there to be systematic differences in either the beginning or in the end, and everything else was kept the same. That was the idea. And whether it's correct to call it underdeveloped, I don't care. Just think about long time to first crack, right? Okay. Should roast like, so Ika, you ask, short roast like the Ikava, does it work with air roasters? No, on the Loring, for example, here, and also if I run only convection with the stronghold, I have longer roast time. So I don't know. I'll try to explain this later, hopefully with Mark's assistance. So Nicholas, I guess a more pointed question on the above is, why is the extended roasting time causing underdevelopment, even though there seems to be more energy applied? Yeah, I just explained that, right? Do you measure the color as ground or whole beans? I measure it on ground beans because what I want to know is the total accumulated energy in the beans. How much energy has been accumulated? And the difference between ground and whole beans is correlates with development time. So or roast time. The faster you roast, the bigger the difference, and the slower you roast, the smaller the difference. And that's very well established. So I don't collect information if I already have it. So the relative color difference between surface and center, I already have just looking at the curve. I know that my friend Michael de Renoir and Rob Hoos, they use the difference between ground and whole beans when they go from, for example, a probat to a Loring when they consult, and they say that they are quicker able to replicate the flavor if they do that, and I trust that that's true. So it can be used, but if it's on the same machine, I wouldn't do it, because I know that the relative differences on surface and center correlates with the speed that I can read um, on the profile already. Okay, Sebastian Klink, do you measure both whole beans and ground? Yeah, just have you done any research that the correlation between the protein and whole bean ground? I think, Sebastian, that yes, because we did a study where we only looked at development time. So that's part of the article package here. So that's the development time article. So we didn't measure actually the color difference, but we did different development time, and we did sensory and chemical analysis of the differences. So Eric Hermann Stoffer, what would you say is usual development time for fruitier coffees? Yeah, 1 to 1 minute 15. But you need high quality greens to pull this off. And chocolatey, that's anything above 2.5 to 3 minutes. It also depends on the roast degree, of course. Yeah, and Joel Norris, how well does your process translate into air roasting? Perfectly. It's most coffee roasters are based on convection anyway, and beans don't care too much about how they are heated as long as they are heated. So it's not necessarily a big of a deal. Mike Ferguson, for the 5% of time to first crack, do you have a recommended slope of rise during the drying and Maillard phase? Say, do you normally prefer? That's the thing, Mike, that now you're asking for a fish, right? And it's not that I don't want to give you one, but it's just machines are different, beans are different. So that's why I want you to get the competences of experimentation and the competences of evaluation, because then you don't need to try to troll the internet for some pointers. Because I don't know what flavor you want to develop. I don't know your customers. And there are so many different possibilities for that you cannot create a theory. So that's why I get a lot of these theoretical questions, hoping for a theoretical answer, which would be the equivalent of giving you a fish, where for me, many of these theoretical questions has a context, which is your particular business. And then you need to be able to answer those questions empirically and not theoretically by doing some experiments and just choose the preference for the flavor goal that you're looking for. So you're never, you never, people ask, how to roast Ethiopian naturals, how to roast espresso, how to roast, and it's all relative. It depends on the context purpose, which is given by your specific customer segments you are addressing. So you don't need these pointers. You need competences, doing your own experiments and your own evaluations. So I don't, and I think it's not wrong to ask the questions, but I think it's wrong to answer the questions, because an answer can never be, has to understand the context, which is the purpose you are trying to fulfill, which is given by the flavor preference profile of the customer segments you've chosen to try to satisfy with your business. Matthias, thanks for promoting science approach and roasting. We need it. Thanks a lot. Look at roasting data to use the but I do find a correlation between short dev and roast area index under the curve, which fruit and chocolate respectively. Oh yeah, so that's interesting. So this is interesting. So Matthias Duran, you are asking about roast area index, the roast around the curve. So where the rate of rise is the first order derivative, that's actually that's the speed, right? Then the area under the curve is the integral, the integration of the curve, which is the area under the curve. And this is an interesting reading because that's the amount of energy. That's a good estimate of the amount of energy added or absorbed of the system. So that could correlate with color. So you are right. Development time is and area under the curve. So the development time and the end temperature, that gives you the area under the curve. So that should be a good estimate for color. But again, it's such an artifact burdened reading the thermometer that I don't think it will be completely precise anyway. And that's why I prefer just good old eye contact, right? Look at the beans that you are roasting. So have your target in the middle and just take them out when you can see that you are closing in on the color. Just start to take out samples, and then you have a big amount you can that develops in color intensity and your reference, and then you can make the right decision while roasting, so you don't have to throw it out after. So it's much simpler. It's nice with math and calculations, but it's not necessary often. Zinc element, I don't know if I pronounced it correctly, I'm sorry, but you ask those Ikawa profiles, do they all have the same bean color in the end? Yes, they have exactly the same color in the end. That's the point, right? Because I want to compare relative differences in time, and then the color, of course, has to be the same. Understanding color intensity is the most measured determining a particular flavor. Yeah, Bob Law, actually, you just say what I've already said about difference between surface and center. Yeah. Guide Sur, why is filter roast around 1.5 minute development time with much less energy? There are usually no crash in the fix, and longer development time, there are much more, especially in wash process and natural, never happen. So if you can see here on this curve, it seems like the exothermic reaction catches up in the end. So if you don't roast for so long, you'll not see this, right? So that's probably the reason why there's a difference, because you're simply not waiting for the exothermic reaction to kick in. Matthias Duran, underdeveloped as long time before. That's correct. I usually hear and say underdeveloped as short time between first crack and drop with peanut and straw notes. In this case, could you say it was underdeveloped? Yes, Matthias, I agree that what is underdeveloped. And I said, in a sense, I regret that I called it underdeveloped in the research, but I had to come up with a systematic difference. So underdeveloped for me is when the coffee doesn't really taste like coffee yet, right? It's still grassy. And this could happen if your development time is too short or if you're roasting too light for the bean that you're working with. So underdeveloped is a relative term. So yeah. Mike Ferguson, when you mark first crack, what do you recommend when declaring it? 2 consecutive cracks or 4th or 5th crack? Oh, I'm not counting cracks. I'm kind of, the way I explain it is that the overall roast is kind of rolling. It sounds like the overall beans are rolling while cracking. But this is the handcraft of roasting. It's certainly not the first individual. It is on the Ikawa. Ikawa is a very small batch. So when I hear the first individual, I feel that's a good indicator of when this crack starts on the Ikawa. Shannon McKay, how do you account for under and over roasting that can come about due to an insufficient or lengthened drying phase during the ramp? When setting roast profiles for new coffees, will you always aim to hit a specific time for first crack, or will you change your approach depending on things like region variety? So I will always start. I'll always start to be with being specific about my flavor goal. So I will be specific about who I want to serve. And when I'm specific about who I want to serve, I'll translate that into a flavor profile. And then I would use that theoretical or that flavor profile, what am I looking for, to choose the greens. Once I've chosen the greens, then I will play around with the color and then development time, just like I showed you earlier. So this way, I'm sure to always make the biggest decision first and then go to smaller and smaller decisions until the decisions doesn't make any sense anymore. How I will account for under and over roasting that come about due to an insufficient or lengthened drying phase. Well, for me, in our research, we've shown that it's a bit the same with time to first crack as development time. It just seems like changes in the roast before first crack doesn't lead to as steep flavor changes as after first crack. So if you want to enhance fruitiness, yes, shorter development time, lighter color, shorter development time, but also time to first crack will also make it fruitier. So under and over roasting, again, remember this is a category, and it's difficult to talk about categorical differences on parameters where the differences are very small. So I would rather that you look in our research and see how are the individual flavor attributes changed when you modulate time to first crack. So over and under roasting, the problem is that they assume that there are big flavor differences, which is not the case with time before first crack if it's not extreme. Vance Coplands, would you say then that having a color measure device is more important to have than bean probes to be able to train the roaster's eye to color? No, I would always have a bean probe and roast logger software because I always want kind of those data. But I definitely also want a color measuring device because otherwise I don't know, I cannot kind of assess how much energy I added to the beans. So I want both. I also want probes and roast logger software, and then I would train my eyes to make the decision because it's all of these in orchestration. QR is not loading. I hope it's loading now. Amazing webinar. I think. Maram Imad, how can we relate the color of roasted coffee beans to the roast profile of roasted type? As some coffees have the same ground color, how are different beans color from inside? Yeah, but this is so, Maram, how can we relate the color of roasted beans to the roast profile and roasted type as some coffees? And this is, remember, we are not doing fundamental research here in the sense that the color reading is something that we need to kind of report. Beans are behaving differently when it comes to color. Beans are behaving differently when it comes to flavor. And that's why you should always have a purpose with what you're doing. And then the flavor and the color is something that locks in the configurations of your profile and settings so that you can repeat it for the customers who preferred the result. So I don't care that different beans react differently. I care about the flavor experimentations I do, and then I can log in my decisions with color and my roast logger software, so I can repeat what I did that worked. Victor Peter, is it mandatory to have the Alubutit R1 available to use for the online roasting course? Victor, yeah, that is necessary if you want to participate on the bullet course. But I also run Ikawa and Stronghold courses online, and Coffee Tech as well in the new year. So you can see on our website, you can see the different courses on the different roasters, but you would need to have one. I have people with completely different roaster, and that works if we are not too many. There's maximum 8 on the courses. So sometimes if there's only 2 or 3 or 4, I've kind of accepted that somebody with a completely different brand is there. So you can just reach out to me if you don't have neither a Bullet, Ikawa, Stronghold, or Coffee Tech, and then we might be able to find a solution. Do roasting technique like soaking count it in time to first crack? That's a good question. And my point is exactly with these data, right? That what happens in the beginning of the roast tend to stay in the beginning of the roast. And the whole soaking is also a thing where I think that it's, what's the point, right? Is it better? How better? That's one thing. It's not specific in better. It's a very vague sensory descriptor because it's relative and it's not specific. I'd like to know how does it become more or less fruity, more or less chocolatey, more or less bitter? So it's a theory that doesn't really predict anything except it's better. And from a thermodynamic perspective, if you're not happy with 100% flame in the beginning of your roast, why don't you just take it to 90 and keep it, right? Rather than heating up the machine, turning off the flame, turning it on again. Sometimes it's like seeing a cat playing on the living room, right? It doesn't have anything, but it imagines a lot of things. So it does a lot of things, but it's just playing with nothing, right? And for me, the soak is just like, what's the point? If you're not happy with the thermodynamic amount of energy you add in the beginning, if you think it's too much, why don't you just keep it a bit lower constantly? And that's why my standard roast, if you're not happy with 100%, try 90, right? Because you're probably playing with something that wouldn't pass the first test unless it's kind of interpreted as, oh, there's too much energy. Why don't you just start lower then? It's not that some people kind of, the beans need to kind of get used to it's just stories. It's just anecdotes. The beans, it's not humans, right? They don't need to get used to being in a hot environment. They are heated up. They can take the heat. They are moist in the beginning. Rob calls, with the roast profile design basics out of interest, where do you start in the experimentation phase with batch size? Do you recommend a specific percentage of drum capacity as a useful starting point? It feels to me there's a lot of anecdotal advice on ideal batch size percentages. And that's exactly, again, my point, Rob. People, we do 90% to be sure. Sure of what, right? What's the purpose? What's the difference, right? Try going with 100% and 90%. See if you can keep the timing the same, color the same, and see if you can taste the difference at all. If your machine claims to be a 12-kilo roaster or a 5-kilo roaster or a 1-kilo roaster, challenge the machine with full batch capacity. And if and only if you can taste the difference between full capacity and less than full capacity, and you prefer less than full capacity, then go with it. Don't do it to be safe, right? If you are adding only 10 kilo in a 12-kilo roaster, the time wasted not roasting full capacity is, you don't get that time back at the end of your life, right? It's time wasted. So my point is, you need to be specific about who are you trying to serve, because who you are trying to serve correlates with different sensory thresholds, right? It might be, okay, For example, on the old 30 kilo roaster that I installed, we noticed that full 30 kilos didn't taste as well as 25, but that was the cooling. We found out that the cooling couldn't keep up. It wasn't anything happening inside the roast, but the cooling couldn't keep up. But for the contrast cafe latte with Robusta, they went 30 kilo, right? Because people added so much milk, they couldn't taste the difference anyway. But if it was for the light roasted Kenya for the shop, right? 25. So you need to not, don't just do what people tell you. Make your own experiments with in the light of the purpose that you're trying to address, and make your own decisions. Anthony Piper, do you think once you have decided on the optimal roast color and time, then you can work on something the roasted rice to be steady and declining? Yeah, you can work on that, but why would you do it? Why would you do it? And then I'm trying to find the slide here again. But can you see you talk about work on smoothing the rate of rise? To me, that's time, right? You need to spend time on it. And if you can't taste the difference, why would you do it? So it's all back to the actual flavor differences introduced in the coffee with what you're doing. If you cannot taste the difference, don't waste the time. So Thomas Compessory, I have only a hot air probe at the exhaust. What would be an approximate difference between that and the bean surface temp? I have no idea. That really depends on your machine. I don't know. If I were you, I would drill in a bean probe to have that information. Anthony Piper, you raised your hand, so I'll just allow you to talk. So Anthony, you can unmute, and if you have a question. Anthony Piper, you raised your hand, and I've given you permission to speak, so to speak. Did you have a question? All right. Okay, I'll crack on with the Q&A. So somebody says that the link doesn't work. I'm a bit worried about that. On my page, it works. So those of you who didn't, it might be that there's too much traffic. So you've got 24 hours to claim the offer. So if the link didn't work, please try again later. It works on my machine. So can you use the profile roast every coffee with it and drop? If I need a Scandinavian filter or dark espresso, is it correct? So I've introduced the standard of the basic roast profile. And my idea with the standard profile is that it's actually a pretty boring profile. This one. It's not very fast, it's not very slow, it's not very dark, it's not very light. So it's really the most boring roast you can think of, which makes it a great starting point, right? So if you want to make, you ask if you can use it as a point of departure for a Scandinavian. So if it was a Scandinavian roast, I might go, rather than go to 60 here, I might go to 80. That would shift first crack earlier, for example, to 8 rather than 9. That would give me more fruitiness, and also a bit steeper development time I could get by going to 30 rather than 20. Then I would get a steeper curve and a more fruitier coffee, and that would be my Scandinavian roast, right? So it's simple decisions like this. So this is kind of your stem profile. You can derive all other profiles easily from this profile. The first reduction point primarily affects time to first crack. And the second reduction point primarily determines the speed after the roast. That is giving you the combination of color and development time that you're aiming for. So that's the idea. So Simona Clark, how would you recommend roasting natural coffees to retain optimal flavor and sweetness? So this is a good example of a question where I don't know the purpose, right? I would note, I would have to know a lot of the downstream things in your company. So why would you end up with a natural in the first place? What's the flavor that you're hoping to get with it, right? And what flavor are you looking for in terms of which customer you are addressing? So that's why, Simona, I think you should train your sensory skills and then get into a habit of asking the questions from the purpose part rather than optimizing. Because optimizing for what, right? You need to optimize for something specific. Agate Micho, I have a question about the difference in color. How much difference in value is significant for the coffee to taste different? Oh, that's an interesting question. And that's actually a question that Ida is working on right now, because she's got 120 people who tasted Action 65, 75, 85, and 95. And she will try to kind of come up with the ranges where people start to be able to perceive differences. And the interesting thing is also that that it seems like the scale is not linear from a sensory perspective. People struggle to taste the difference on the lighter end of the scale, where it's easier in the darker end of the scale. So that's something you can expect us to release in research in a few months. So Ben Roberts, why do you target first crack at 9 minutes? Is there a time to first crack you would consider too long or too late? And so Ben, this is it's a bit arbitrary. And remember the control part here. I'm not telling you this roast tastes good at all. I'm telling you that when you're able to do this roast, you're able to make a roast on the machine, your machine, that's not very light, is long or very short. It's not very light and it's not very dark. So once you have the blueprint of the speed of your machine, when you go to the experimentation state, you can do whatever you want, right? It might be, you can try, for example, with a stronghold to get first crack at 7 minutes and see what happens. But you're just much more systematic and can easily do whatever you want once you have exposed the standard roast on your machine. Once you've exposed the standard roast on your machine, it's so easy to go to the next step where there are no rules, right? So 9 minutes, it's a bit arbitrary, to be honest. It's just what I happen to find the best on all the machines I've been working with always, but that doesn't make it a sensory preference, and that's not why I recommend it. So the whole point of the control part here is exactly to create. Also, if you were to learn how to drive a car, right, and they made this kind of confined track to teach you how to control your vehicle, this track could look different, right? It's a bit arbitrary what bends are here, but they are useful for you to learn how to navigate your vehicle. So that's why don't get too hung up in these specific points anyway. You need to get hung up in them very precisely during the exercise, but only for the sake of doing the exercise to get to know your vehicle, not because they are a superior flavor at all. How does chart temp influence your time markers of 3 minutes? Yeah. So the charge temp on my bullet, I actually go to 310. I max it out. So Andreas Bashik, um, you ask about my charge temp, and on the bullet, I wasn't too happy with the speed when I loaded it with the temperature that I load normal machines at, which is typically around 200, 170 for the Stronghold, 190 for the Coffee Tech, 220 for the Probat. But the bullet is a bit special because it accumulates a lot of energy in the drum. It's an induction roaster, so it heats up a lot. The drum, there's a lot of heat capacity there, and I wasn't too happy with the speed, so I really just thought, okay, why don't I just try to put a lot of energy into the drum? And then I got some roasting times I was really happy with. And Reza is roasting here in the background on the small 1 kilo Loring we have. And we played around with the difference between the different roasters in here. And when I maxed out the bullet to 310 starting charge temp, we got really nice flavors. So that's my preference from now on, based on how the flavors come out. So 310 was my intensity or starting point. All right. Simona Clark, can you use rate of rise as an indicator of what's going to happen next in a roast? Yes, that's exactly what I think you can use it for. And it's useful for that, just like the speedometer in your car. Jake Hansen, when you classify roast as underdeveloped, what is a common action reading for the coffee? Yeah, Jake, I don't know because I'm not too sure about the concept of underdeveloped. It can be defined in so many different ways. The way I did it in the research, I regret a bit. I tend to agree a bit that underdeveloped is probably if it hasn't been kind of dark enough after first crack, so it's still grassy or and somebody says that yes, give me this offer doesn't work on the offer page. I'm just checking on mine, and I think it's working. So please just give it. Yeah, it works on mine. So just if you try to claim the offer and it didn't work, please just try again. Sergio Kusevsky, do you soak coffee? No, I don't. I think it's if you're not happy with the energy you start with, if it's too hot, just start lower. It's a waste of time to make it's another example of overcomplication that Occams Racer is trying to kind of avoid in research design. Uh, there's a lot of people saying that the offers button is not working, which is really annoying. The website is WordPress based, so it's a bit unstable, and probably if a lot is on the page. So please try again if it didn't work. So uh, so Sean Tan asked, what grind size do you use when measuring ground color intensity? I grind as fine as possible without clumping. So the coarser you grind, the darker reading you will get because of scattering effect. And the finer you grind, the more correct because you don't have the scattering effect, or that's reduced. But at some point, it's so fine that it starts clumping, and then you have another source of scattering. So I would grind it as fine as possible without it clumping when I distribute it. On the color track, it doesn't matter because it's a laser and it doesn't care about grind size. The Tonino also is great because it grinds so fine that and you compress it. That's a great way of doing it. So it depends on the technology you also use. Oh, that's a lot of questions. So I'm trying to take the ones I haven't answered before. Jane Qua, in the roasting profile, you mentioned 3 flame settings to and first crack in 9 minutes, 3-minute development time, and Actron 75. Does this mean that you have 3 minutes to get to Actron 75? Yes, that's exactly what it means. How important is it to track roast phases? Well, yeah, in phases, well, I don't track yellow and cinnamon because that correlates with what I do with first crack anyway. So if I get first crack earlier, I also have yellow and cinnamon earlier. So I don't track it because I already have the information. George Spihakis. Hi, George. You've been on all my courses, I guess. I'm a bit confused regarding the underdeveloped graph. Yeah, from a theory aspect, we are expecting a sourness and a lighter body from underdeveloped batches, plus some unwanted flavors from unripe fruits. How that batch wasn't noticed from people that tasted it. Yeah. Yeah. So again, I'm not sure. I regret that I called it underdeveloped. It should have just have been long time to first crack. Mike Ferguson, we found that a longer Maillard time than drying time causes more baked flavors. That's why I'm curious what you recommend for how long drying versus Maillard. Yeah, and Mike, then I'll ask, are you sure? Did you keep color the same? Did you go through these kind of discriminative tests to see if you could actually taste the difference, provided that you got the same colors? Because I think, yeah, you can take, there might be some small differences before first crack, but it's really not a lot. And I don't recommend anything, right? I'm not giving you a fish. I'm telling you, I'm asking you to do your own experiments, see how that shift the flavor. And because you will find that for some customer segments, it's better to extend time to first crack. For some customer segments, it's better to make it shorter. So that's why I don't recommend anything. I recommend you to be able to trust your own experiments and trust your own evaluations and make your own decisions when it comes to the difference between how it tastes and who you're trying to serve. Chris Romero. Yeah, Chris Romero. Yeah, you also have problem with clicking, and you should also be able to get it in the USA. Shouldn't be a problem. So you say that the QR code is not working. There's a lot of problems with this. I'll just check the QR code myself with the phone here. And my end, it works. So I'll recommend you to just try again. Yeah, I think time-wise that we will have to stop now. So there's a lot of questions still. I'll try to go through them and get inspired to next webinar and see if there's something that. So basically, there's 142 questions. So I hope you understand that I can't go through them all, but I will upload this to YouTube. And if you keep a picture of the QR code, please try again if you struggle to get the offer. So thank you so much for attending, and take care.